All right, first section of chapter 3, we're dealing with reflections. So first thing I want to talk about is what a rigid motion is. So everyone, off to the side of example 1, I want you to write the words rigid motion. Off to the side of example 1, write the words rigid motion. We're going to write some definitions here. So a rigid motion is a transformation that preserves length and angle measures. Let's break that down a little bit. What does preserve mean? Keep, stay the same. Preserve means you're keeping it the same or you're trying to save it. Okay, so we're keeping the length and the angle measures the same. So go ahead and write the shape stays the same. And you can refer that to size, stays the same size. Okay, so for example, talking about reflections, what did you say a reflection is?
Just a mirror image.
It's a mirror image, it flips, right? So was our shape changing size during those reflections? No, all that was happening was just flipping. Yeah. So the reflection is a rigid motion. Okay, what about a translation where it just moves? Is that a rigid motion?
Yeah.
Yes, size isn't changing. What about a rotation?
Yeah. Yes.
That's also a rigid motion. What is not a rigid motion?
Dilation.
A dilation. Why is a dilation not a rigid motion? Size changes. A couple notation things here. Whenever you see the word pre-image, pre means first. Okay, that is my first image. Okay, that's the original with Roman numeral 1 as its label.
Why?
Okay,
Just
because. Yep, it uses with the Roman numeral 1. So the image is the second image. That's going to be with a Roman numeral 2. Okay. So on this example here, from pre-image to image, is that a rigid motion?
No.
Why not?
Because it's a dilation.
Because it changed size, right? And it's a dilation. So this one right here is not a rigid motion because the shape did not stay the same size. Okay. So what I want you to do, take that information in your groups. Go ahead and talk about example 1, A and B. Say yes or no if it's a rigid motion, and then tell me what's happening. Go. All right, example 1, remember, pre-image is our first, image is our second. So we're going from here to here. Was that a rigid motion?
Yeah.
Yes. Why is that a rigid motion? Didn't change size. What happened? Rotated. Yep. And part 2, or part B, from pre-image to image, is that a rigid motion?
No.
Why is that not a rigid motion?
Change size.
It changed size, it got bigger, so this would be a dilation. Okay. I'm going to take a look at example 2. It wants you to sketch the reflection of that triangle. Now, what makes this one a little tricky?
No graph.
There's no graph, okay? We're always going to have a graph except for this one example here. But I want to talk about notation things real quick. So if we rotate or reflected M, so do you agree M is this far? What do I have to do on the other side? That far, about that far. So guesstimate there. When you have a new coordinate, so from the original M, we got our new M. We're going to label that as M prime. Okay, so we went from M to M prime. Go ahead and do the same thing for L and N. And once you have all 3 points, go ahead and draw your picture. How can you check if you did it correctly?
They're the same size.
Should be the same size, okay? And they should be the same distance away from the line of reflection. Okay, so it should stay the same size, should stay the same exact shape. Again, this is the only one we're going to have without graph paper. Okay, but biggest thing I wanted to talk about, your original image is just the regular letter. Your new image is the letter with the prime symbol or that apostrophe. Okay, that keeps them separate. Because when we get on graph paper, it's going to get really messy if we do this on every single one. Okay, so that's why we use the prime symbols. Okay. All right, here's where your graph paper is going to come into play. Go ahead and grab your graph paper. Okay. We're going to be on example 3. On your example 3, you see how it has these 3 coordinates here. I want you to graph those on your graph paper. Graph those on your graph paper. This is going to be graph paper you want to keep as your notes because we're going to use it every single day. Okay? So go ahead and graph those. I'm going to graph them up here as well. You can double check. When you graph your points, watch, I graphed my point. You need to label it with whatever vertice that is.
I have to count all these numbers. There's multiple.
Will we do X first?
Yep.
So like X becomes before Y now.
Okay, so your picture, your original image should look like this. Okay, and if you want to label on your graph paper, this is example 3A on your graph paper. Okay, notice on 3A, it has R and then sub x-axis. Okay, what I mean by sub, if it's a subscript right below it. What do you think that R stands for?
Rotation.
What are we talking about today?
Radius.
Reflection. Okay, reflection. What do you think this is for? What you're reflecting over. So this right here, label this in your notes. This is your line of reflection. Okay? Do you agree the x-axis is already bolded for you? Yes. Are we always going to be reflecting over the x and y-axis? No. Okay, so what I want you to get in the habit of is I want you to label it even more. Okay, so you know this is the axis that I am rotating over. So go ahead and label that. Even if you go like scribble a little bit to make it a little darker, do that. Okay, so we know that is our line of reflection. That's what we're rotating over. So I'm just going to go in alphabetical order here. What do I do with A? Like, how do we perform this reflection?
Count how many it is away from the line of reflection.
Count how far it is away from the line of reflection. So this one here from A, 1, 2, 3, 4, 5, 6. So how far do I have to go on the other side? 6. 1, 2, 3, 4, 5, 6. What do I label it? Yep. A prime. Yep.
Wait, what did you just do?
Counted the distance.
I got it.
Okay. I'm just going to go in alphabetical order. How far is B from the line of reflection? 2. So I need to go 2 on the other side. What do I label it?
B prime.
B prime. C?
C prime.
4. So I need to go 4 on the other side. Once you have all your points, graph it, draw it. Okay. Now, some of you might like that I have 2 separate colors here so you can visually see it better. I am totally cool if you want to use pen colors. Okay, I'm cool with that. If you would rather do that, I'm good with that. Okay, because you can see that a little bit better. Okay. While you're getting those out, go ahead and listen real quick. What I want you to do, we are also going to do part B. So what you need to do on another graph on your paper, draw your original coordinates again. Draw your original shape again.
Okay. Oh, what? Original shape. Oh, shoot.
Using the same coordinates, right?
Same coordinates, yep. Okay, so you should have that original shape on a different graph again. So this is your example 3B in your notes. What does 3B tell us?
Reflection across the y-axis.
Reflection across the y-axis. So what is our line of reflection? Y-axis. What do I want you to do with your lines of reflection?
Count over.
Bold it, draw them, yep. Because remember, your line of reflection is not always going to be the x or the y-axis. So it's not always going to be easy to see. So I'm just going to go in alphabetical order. How far away is A from your line of reflection?
5.
It is 5, so I'm going to go 5 on the other side. What do I label it?
Prime, number A.
A prime. B, how far away is
1.
B? 1, so I need to go 1 on the other
B
side.
prime.
And C.
3.
3 to get C prime. Again, draw your picture once you got all 3 points.
You want to draw your picture.
How can you check if you did it correctly? What should you see?
Reflection. Mirrored image.
Mirrored image. You should see the same shape, yes?
Yes.
Remember, it's a rigid motion. The shape should not have changed. Okay, if you for some reason had your A point all the way over here, did you probably do something wrong? Yes. Okay, so check in that way. Your shape should stay the same.
I for some reason just put a line for no.
Okay. A and A and A prime should be straight across from each other, wherever that line of reflection is.
Erasable pens.
Okay, on example 4, the directions tell us what is a reflection rule that maps each triangle to its image. So if we're looking at 4B, I'm going to skip A. 4B, notice it gives us F, G, and H as our original. What are these ones over here? The prime, which means the new image. Okay, so what I want you to do on your graph paper, so this is going to be our third graph, I want you to graph both of those shapes. So you should have 2 triangles on one graph.
I love it.
Capiche?
Will they be,
2 triangles on one graph.
will they be mirrored or will they be different?
They should be mirrored already. Yep. So go ahead and graph those. I'm going to pause the recording so I can graph that. Again, when you're graphing, just make sure that you are labeling your vertices as you go so you know which ones are which.
I don't really understand all that, why I gotta graph this. I would agree with you.
What was your question?
I would gotta graph all the vertices and whatnot.
Yeah, it's not mirrored.
Yeah, it's not.
It's different. So.
Guys, stop listening now.
Just do
Okay, here's the challenge. If you have this graphed already, I'm going to challenge you to find where the line of reflection is. If you find it, I want you to draw it. Okay? I'm also going to challenge you to try and put a name to it. I'm going to give you about 1 more minute here. Now, for all the transformations that we're going to do, we're going to have to work backwards and try and find what the rule is. Okay? So, with lines of reflection, the only thing you have to figure out is what the line of reflection is. Okay?
I know.
So, you could look at the whole image, but I highly recommend that you just pick one of the points. Okay? I'm going to pick F just for an example. Okay? So, how do we find where that line of reflection is between F and F prime?
I mean, count the numbers in between the
Count it
letters.
and then divide by 2.
You count the distance, right? So if I count the distance between F and F prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that whole distance is 12. So how do I find the
6.
middle of that?
Count 6 from one of the lines.
12 divided by 2 is 6. So I'm going to go over 6. 1, 2, 3, 4, 5, 6.
Why didn't you just do that with the bottom?
So we got it right here. I just did an example. Yep, some of you are like, why didn't I just do G? I just did it as a bigger example up here. But same thing with G. It's 2 apart, so what's the midpoint of that?
Probably the middle one.
1, right here. Okay, you can also check with H. H would also fall here. So once you find the line of reflection, I want you to draw it. Go draw it in your picture if you haven't already.
But what would that be called?
Okay? Is that X or Y axis? No, it's not directly on there. Okay? Is there a specific point that it goes through?
1.
X equals 1 or Y equals 1?
X equals 1.
That's your answer.
Ooh.
So our line
That's what I thought.
Our line is X equals 1 because it went through the point 1 on the X axis. Okay? So, we're going to talk about different lines other than the X and the Y axis. So, go ahead and label vertical lines of reflection. Off to the side of example 4. Vertical lines of reflection. Okay? What direction is vertical? Up and down, okay. What axis is up and down? Y axis. Yep, so that's one of our options of a vertical line of reflection. We just figured out that the other option for a vertical line of reflection can be X equals some number. I'm just going to put a question mark for now. Okay, what this question mark means, it's what point the line goes through on the on the X axis. So just like what we saw with X equals 1. That was a vertical line going through the point X equals 1. What is the opposite of vertical? Horizontal. So horizontal lines of reflection. What direction does horizontal go? Side to side, yep. What axis is a horizontal axis? Yep, so x-axis. With the x-axis, okay, or horizontal lines of reflection, what is that going to go through now if we move that line up and down? It's going to go through the y, so it's going to be y equals some number. Again, what that question mark means, it's what point the line goes through on the x-axis. Yep, sorry, thank you. Y-axis.
Yeah, this is like walking.
Okay. Another thing I want to take note of real quick. Last thing. These do not have to be perfect. Right underneath what you just wrote, I just want you to draw 2 coordinate planes. Okay, just go ahead and draw 2 coordinate planes. They do not have to be perfect. I don't want you to use your graph paper on this. Okay? Remember at the beginning we talked about diagonal lines?
Yeah.
Okay? What would the slope of this line be if it goes through the origin?
45.
Slope, it's up 1 over 1. It is up 1 over 1, and it's positive. So what this one's going to be, this is y equals x. That's the line of reflection. What is it going to be if I make this go down?
Y equals negative.
Y equals, nope, it's actually y equals negative x because our slope is negative. Okay, I will show that a little bit more on the thing of why it's a slope of 1. Okay, but for now, just worry about this. With the diagonal lines, it will always be through the origin, so these lines will never change. I'm not going to move the line up and down. Okay? All right.